From JA Solar, Lida Guo is going to talk about challenges and industrialization progress of N-type technology. Lida is a senior product strategy manager at JA Solar Technology. Lida, without any waiting, please start your presentation.
Okay, wait a second. I'm going to share my screen. Can you see my screen now?
Absolutely.
Okay, my full screen PowerPoint, right?
Yes, full screen.
Okay, wait a second. Hello, everyone. I'm Lida Guo from JA Solar. I'm glad to have this opportunity to share with you the challenges and industrialization progress of N-type technology. I've divided my presentation into three main parts. First, I'd like to introduce the development of solar cell technologies. Then I will talk about challenges of N-type technology. And finally, I will show you the industrialization progress of JA Solar. So first, let's start with part one. As we all know, in recent years, the efficiency of N-type cell has been increasing, and the mass-produced cell efficiency has hit 25%. It is expected that the production capacity will be further expanded in the next 1 to 2 years. And another promising technology is the perovskite and silicon tandem solar cell technology. The efficiency will possibly exceed 30% in the next 5 to 10 years. The picture on the right gives us the solar cell efficiency roadmap of JA Solar. Now, JA Solar is producing both P-type and N-type solar cells. The average cell efficiency of PERC has reached 23.7%, and the efficiency for N-type is over 25% now. In the year 2025, these two numbers are expected to reach 24% for P-type and 26% for N-type. In addition, we also plan to develop back contact solar cell technology and also the tandem solar cell technologies. Well, besides the efficiency in the industry, you may also want to know, is there a limit for the efficiency? The answer is yes. Here, this slide gives us some theoretical limiting efficiencies. As can be seen here, the limiting efficiency for P-type PERC solar cell is 24.5%. And as I just mentioned, now the average efficiency in mass production has hit 23.7%, which is really close to this limit. So further improvement of PERC becomes difficult to achieve. There are several main pathways for silicon cell technology beyond PERC. For example, HJT with limiting efficiency of 28.5%, and bifacial TOPCon with upper limit efficiency of 28.7%. With promising efficiency potential, N-type technology will definitely play an important role in the future. As can be seen from this picture showing the market share prediction, in the next 3 to 5 years, the P-type PERC module will still be the mainstream PV product. At the same time, the proportion of N-type module will gradually increase and will possibly become the next mainstream technology after PERC. As we all know, opportunities and challenges always come together. So next, let's move to the second part, challenges of N-type technology. First, let's have a look at the process and equipment of TOPCon solar cell. TOPCon technology is an upgraded technology of PERC. It adopts the composite structure of backside oxide layer and doped polysilicon to form a good passivation contact and improve the performance of the solar cell. The TOPCon cell production line is compatible with most of the existing PERC production equipment. As can be seen from the figure here, The compatible parts are in white boxes, and only the equipment in the blue boxes need to be added to complete the upgrade from PERC to TOPCon. This equipment are used to form titanium oxide and polysilicon layers. Now there are mainly 3 technical routes: LPCVD, PECVD, and PVD. The upgrade investment is small, only $7 million per gigawatt. And if you build a new line, it will cost about $27 million per gigawatt. On the contrary, the equipment cost for HJT is much higher. It's about $63 million per gigawatt. So easy upgrade, acceptable equipment cost, and high potential for efficiency improvement will boost the development of TOPCon technology. However, there are still some challenges for each technical route. LPCVD is the first and widely used deposition method for TOPCon solar cell processing. Although in situ doping can be realized by LPCVD, but due to poor uniformity, most manufacturers instead prefer the approach of intrinsic poly followed by this phosphorus diffusion, this one. One of the challenge is the wraparound film, as can be seen from this picture. The polythin film is not only deposited on the front surface of the substrate, but also at the side and back side of the back surface of the substrate and coarse carrier. The wraparound film can result in the decrease in the optical and electrical performance of the cells, such as open circuit voltage, short circuit current density, and fill factor. And it requires extra cost and equipment to remove this wraparound film. In addition, due to severe deposition at coarse wear, the coarse wear needs to be replaced frequently, and this brings up the production cost. Another challenge is to reduce the process time. Now it requires more than 2 hours to deposit the intrinsic polysilicon film. Another way to fabricate TOPCon is PECVD. The wraparound film is light, so it is easy to remove and clean. The disadvantages are lower thickness uniformity, less dense film, and lower cell efficiency. The cell efficiency is now 0.05 to 0.1% lower than that made by PECVD. So the main challenge here is to further optimize the process and achieve higher efficiency. And because of higher production capacity and low cost, more and more manufacturers choose this route. The third way is PVD. As can be seen from this picture, the target atoms go from the target to the substrate directly, so there is no wraparound problem. However, the equipment cost is high and the target needs to be replaced frequently, so this leads to low uptime and high operating costs. I think this is why PVD hasn't been applied in large-scale production yet. Next, I'd like to talk about the challenges to achieve higher efficiency. The first one is selective emitter. The emitter region below the contact can be heavily doped to reduce the contact resistance. As we know, for PERC cell, the selective emitter is a standard process which employs the green nanosecond laser. However, TOPCon requires laser with higher energy because the solid solubility of boron in silicon is lower than that of phosphorus. So if we use the green laser, it will easily cause damage to the TOPCon cell. So it is important to find the laser with proper wavelength and power. Now, ultraviolet laser could be a good choice. With optimized SE process, the efficiency can be further improved by 0.4%. The second one is thinner polysilicon, which will reduce the undesired light absorption and allow the cell to capture more light, thereby increasing light-generated current. And the third one is better materials such as N-type wafer with higher minority carrier lifetime. It will reduce the recombination rate of the cell. And the last one is to further optimize the process. For example, minimize the laser damage in SC process. If we use a thinner poly, the firing process needs to be better controlled to prevent metal contact from going through the polysilicon layer. And during the phosphorus diffusion, the diffusion depth needs to be well controlled. It shouldn't pass the silicon oxide layer. Now we have gone through the challenges of equipment and technologies. Next, let's have a look at the cost challenge. At the moment, the production cost of N-type is still a little higher than P-type product, as can be seen from this figure. For N-type, the cost of metallization, passivation, and the wet chemistry are higher than P-type. Accordingly, there are several ways to reduce the costs. The first one, optimize the metallization pattern and use alternative material to reduce the cost of silver paste. And the second one is to optimize the manufacturing process. And the third one is to use larger size wafer and equipment with a higher production capacity to boost the productivity. And the last one is use thinner wafer and optimize wafer sawing to reduce the material cost. With all the approaches I just mentioned, we believe that the cost of N-type product will keep decreasing and will be close to that of P-type in the next 2 to 3 years. Now, with the progress of the whole industry chain, we believe that the N-type product has come to a point where everything is ready. So in May this year, we launched our N-type product. So next, let's move to the last part, industrialization progress of JA Solar. The N-type product is called Deep Blue 4.0X. It is a top product based on the latest high-efficiency N-type cell technology and also advanced module technology. It opens up an infinite future. That's why we call it Deep Blue 4.0X. Here, this X means infinite potential and infinite future. The highest efficiency is 22.4%, and the power is up to 625 watts. We have designed 3 types of modules, the 54-cell module, 72-cell, and 78-cell module. This 54-cell module with smaller size is perfect for rooftop projects, while the larger ones are more suitable for CNI and utility scale projects. Here, another thing I would like to mention is the module size, as can be seen here. The module size is identical with the mainstream P-type module size. So our N-type modules are compatible with current system design and installation. Regarding the 54-cell module, we have also designed a high-end all-black format. We conduct excellent control of cell colors and use gapless module technology. So our all-black modules have higher efficiency and very good appearance. They just look like panels of colored glass. In addition, we use thinner double glass here, so the reliability is better, but the weight is the same as regular single glass module. Therefore, they are excellent choice for rooftop applications. Besides N-type cell technology, we have also applied advanced module technology for our new product. It is called GFI technology. Here, the full name is Gapless Flexible Interconnection Technology. It is JA Solar's patented technology. Here, we use regular round ribbon and special cushion design to deal with the mechanical stress at this cell connection, so we can realize the gapless connection between the solar cells. as you can see in this picture. It will bring much better appearance. GFI also eliminates microcrack problem for high-density modules and ensure higher module reliability. In addition, with this GFI technology, the module power is increased by more than 5 watts, and the module efficiency is at least 0.2% higher. Here are some features and advantages of Deep Blue 4.0X based on advanced N-type solar cell technology and GFI module technology. It has higher power and efficiency, lower degradation, lower temperature influence, and higher beneficial benefits. The beneficiality is about 80%, while for P-type it's normally 70%. And a better low light performance. And the last one is excellent reliability. Next, I'd like to share with you some data from our demonstration project and simulation. JA Solar and TUV Nord launched an energy yield test in the northwest of China. We compared the performance of the Blue 4.0X and P-type module. The results show that the power generation of N-type module, the yellow one, it is 3.9% higher than that of P-type module, the blue one. So this excellent power generation performance will definitely help reduce the BOS and LCOE. We made simulations of a 100 megawatt project in Dubai and compared the BOS and LCOE of Deep Blue 4.0X and the P-type module. The BOS for N-type is 2.1% lower, and the LCOE is reduced by 4.6%. Finally, I'd like to show you the planned production capacity of our N-type product. The capacity by the end of this year will be 1.3 gigawatts, and it will be expanded to 27 gigawatts at the end of next year. In the future, we will adjust the capacity to match customers' demand for high efficiency N-type modules. All right, that's all I want to share today. Thank you all for your attention.
Okay, thank you. Thank you, Lida. I think that's a very impressive plan from 1.3 to 27 gigawatt. That's really looking very great. So quickly, one question is, you have Deep Blue 4.0. So there are also a lot of TOPCon modules available. So what are the most important differentiating factors with Deep Blue 4.0?
Okay, actually Deep Blue 4.0X employs the advanced N-type cell technology and also the JA Solar's patented GFI technology, as I mentioned in the report. It is called gapless flexible interconnection technology. And this technology improved the module efficiency by 0.4% and also power by 5 to 10 watts, depending on the product. This makes Deep Blue 4.0X the most competitive N-type product in the current market. And together with more reliable quality assurance, Deep Blue 4.0X can bring better power plant revenue for customers.
Okay, so one more question, like, it may not be really fitting into the topic, but I'm just curious, like Jay now has announced about the big plans for TOPCon. On the other hand, you also are among the companies that have a completely focus on TOPCon, and it will also continue to work on heterojunction. So in few words.
Okay, actually, we see both TOPCon and HJT as promising technologies for future mass production. But to decide which technologies to be mainly adopted in the end, there's a lot of things we need to consider. We need to consider the whole industry chain, including equipment and process maturity, material cost, and equipment and production cost, and so on. Now the efficiency improvement and cost reduction are on the table. And what we need to do is to find out whether they are feasible in mass production line. So in the end, we will choose the technology which can bring lowest LCOE and highest customer value.
Okay, then one more question. So very quickly, what are the top two bottlenecks for TOPCon, if there are any in your view?
Okay, bottlenecks. Well, we would say there are still something we could do to improve the performance and the product yield of TOPCon cells, such as improving the minority carrier lifetime of wafer and optimizing polysilicon deposition process, and also exploring advanced module encapsulation technology and so on. The main purpose is still to further improve product performance and quality, further reduce manufacturing costs, and finally meet customers' demands and needs in multiple dimensions at the same time.
Okay, thank you. And please stay back and answer any questions. May not be directly to JA, but if there are any questions related to TOPCon, you are really welcome to answer them in the chat.
Okay, thank you. I'll stay for a while. Thanks.